Hello, friends. We are back talking about PIDs again. So we are kind of been building up to this. We've talked about, well, actually, we've hit the basic instructions. We've talked about analog. And then in the last few videos, we have set up our PowerFlex 525 and our encoder feedback for this PID. And then we talked about how we're going to do some trending in it. Now let's go ahead and do a quick recap. Oh yeah, before we do that though, I dropped something in the chat. Answer 3 questions for me. Where do you work? Where are you located? And what are you currently working on? Sometimes it just helps me with ideas and to get to know you a little more. Also, we had several people complain in the last few live streams. Are like, hey, we didn't know about it until afterwards. Well, yeah, you got to hit that subscribe button if you want to know about our live streams beforehand. But okay, let's talk about what we've already done in the previous ones. Is if we go over to the Micro850 in the left pane and we go into modules, we added our PowerFlex 525 drive and our IO link over Ethernet. And then we actually did a little learning about structured text and managed to program our encoder rate. And then we did some ladder over here to figure out how to do our drive speed command. And mainly, the only thing we have right now is our hand input, which is switch 4 left. And if I switch 4 to left, mainly we're going to look at the speed feedback. The motor starts, and we're getting feedback. So in this video, we're going to talk through how to actually start integrating these two into a PID. And so I'm going to go ahead and disconnect from this. And it's funny, actually, yeah, I have to tell about another one. Several people have complained. We just want to know about the PID. Why do you keep telling us about everything but the PID? Well, all these things are important, and even in my class, somebody will like, yeah, I want to learn about a PID, and I'll just sit down and be quiet for a second, and the first thing to do is they drag the PID instruction down. I'm like, well, what are you doing that for? It's like, well, we want to learn about the PID. I'm like, yeah, I know, but we got to do some prep first. So really, the last few have been getting our data, being the process and control variable, ready for the PID. And the next thing we really need to talk about is the update rate. Like, how often do you want this PID to update? And I asked this question, and usually people are like, as fast as possible. And that's usually not the case. Now, there are some that can be super fast, but if in our case, we have both of these controlled over Ethernet. So if and actually we'll go look at, actually let's go and look at it now. Our update rate, our RPI, which is how often this is updated, is 20 milliseconds on the drive and 20 milliseconds on the IO link. So right there, and I don't know, some people argue whether you count that as 20 milliseconds or you add them together in 40 milliseconds. Anyway it goes, if we make a PID that's updating every millisecond, we're not going to get an actual response to whatever that PID is doing for 20 times of it doing it. So I'm not going to get into what the update rate should be, because one really cool thing about this setup is we're going to be able to play with it a little bit, because we also have Excel and decel on the drive. You got all types of external variables that can be in there. But for ours, what I want to do is I'm just going to arbitrarily make it 500 or no 200 milliseconds. And yeah, there's no science behind that, because really I just want us to understand how to do the PID so that we can learn about it. Now, we could put this into our main program and do some stuff and make it fire every so often, but usually you're going to see these, well, especially in studio, it'd be a periodic task. But in this, we're going to make a program that will fire every X amount of seconds. And so if we double click on the Micro850 at the top, we have an interrupt section. And right here, we can configure a program as an interrupt. So a little bit about the way the Micro 800 scans is we have programs in here. Well, right now it's hitting program 1, then program 2, program 1 and program 2. And it's pretty much doing that just back and forth. And let's go ahead, let's go and rename these a little bit just so for our slight sanity. I'm going to call this I'm going to call it our main, because I couldn't think of what to call it on the fly. This one right here is our encoder rate. Oops. Oh, can't have spaces in names. I ought to know that. One of these days I'll learn that. There we go. And now let's make another one. So I'm going to right click, programs, add. And since we've done structured text and ladder in this series, this time we're going to use a function block diagram, which is arguably what I see most PIDs done in. And I'm going to call this my PID. Oops. And yeah, there are some kickers to the name. Since PID is an actual instruction, you can't use that. So we're going to call this our PID control. There we go. Okay. So the way this will work right now is it's going to run the main program, encoder rate program, PID program, and repeat. And it's just doing that back and forth. In fact, let's go look and see how fast it is doing that. We're going to open our controller variables. And then if we go down here, oh, well, I got to go back online to do that. So we will not do that. I'll try to remember to do that later. But it's doing it incredibly fast as possible. But when we say as fast as possible, that's not necessarily consistent. So sometimes maybe it's 1 millisecond, sometimes it's 5 milliseconds. So with that variable there, it's going to be really hard to operate a PID. So now what we're going to do is we are going to go back to the Micro850 in the left pane. And in those interrupts, we're going to click add. And then we are going to select a selectable timed interrupt. And so what this is going to do is it's going to run a specific program at a specific time. So we're going to select the PID control. And yeah, I'm going to make that 200. And then there's an auto start button here. And I am going to click it because I want this thing to run all the time. Now, pay attention here to the PID control when I click OK. So we end up with that little red thing, and I think it actually says something there, but I've never been able to actually read it. And so that means this one is going to run at the selectable time interrupt. Okay, so let's open it up. And yeah, so this one looks kind of like a piece of chart paper. And instead of us having the instructions across the top, we have our toolbox on the right side. And let's drag in an instruction block. And then we'll double click on it and start typing PID, and you're going to see two of them come up. We have one that is similar to the MicroLogic's PID, and then we have the one with the auto tune, and we're going to be using the one with the auto tune, the iPID controller. We'll select it. And if you recall from our earlier video, remember how in this one we had to widen this up and it made everything ridiculously wide when we did that. One really nice thing about working in function block diagram is I can select this and I can individually widen out these blocks. Now we don't want to go ridiculously wide, but get this to where you can read all these words right here. And then we're going to start bringing in variables to create some items. Now, if I drop it right here, notice it just drops. If you drop it close to where it needs to be, it actually puts the line in for you, which is really nice. So we'll go ahead and drag some in. And actually to start with, because we'll end up taking a few of them out, but to start with, I'm going to drag one onto every single one. And then we can talk about what all we're going to do here. Okay. So first we have our process. The process is that value that we're wanting to, or not that we're wanting to control, it's the observable change in our PID. So if this was an oven, the process would be the temperature. The output would be the butterfly valve or whatever is turning the heat on it to that oven. So in this case, we already, from our previous video, made, oops, if I can get to the right tab, because we just renamed them. Now it's called the main tab. We have the speed feedback, and that is telling us our encoder speed. So we're going to put that in right here. So speed feedback. All right, then we have a set point. We have not determined our set point yet. I'm just gonna, no, one thing I don't talk about a lot, but I probably should, is if you click the top of the box, it's gonna give you a drop down that you can select or you could type. If you double click on the bottom, it brings up the whole thing. So I'm gonna call this our PID set point, and it will be a reel. All right, now we have the feedback. We're gonna come back to the feedback in a little bit. For now, I'm just gonna delete that block out because we need to spend some time on it. So next we have auto. I'm gonna call this PID auto. And then we have initialize. Call it PID initialize. Oh boy, now you're gonna laugh at my spelling. I think that's right. Then we have PID gains. Notice as we're doing this, it's knowing exactly the data type that we want as we go. PID gains. Oop. Okay, same deal. Since there is a PID gains data type, we can't use that. So singular, PID gain. There we go. And then we're going to have PID auto tune. And we have our auto tune parameters. Call it PID. Oh, that's bad. Oh, now I'm really brutalizing it. PID auto tune parameters. Okay, now on our output side, this is what do we actually want to control? Now, we haven't really talked about it yet, but if you notice, only this one, compared to especially if you've been in Studio 5000, this is all there is to this. So we do need to think a little bit about the future here is mainly, would we ever want to maybe have a manual control? So while I could point this directly to, where is it? Our speed command, I may not want to do that. I may want to, in fact, we should have a handoff auto here to control that. So we'll build that out in a little bit. But for now, we're going to call this our PID output. Oops, and I forgot, I need to hit the bottom of that. And then we have our PID error. And our PID AT warning. And our PID out gains. All right, that gets those roughed out. Let me pop over here to the chat, see what we got going on. Vernon, you work at TMB2, yeah, in Northwest Indiana, installing remote I/O on Mill 2. Well, that sounds like a lot of fun there. Well, look at there, Amber Wilborne. She's in the chat. She's at home today. I was like, I cannot cancel this live stream again because it's been canceled for snow, canceled for a power outage, and yeah, we're both actually sick. So I was like, no, I'm gonna go ahead and do it. Austin, Vinyl Max in Hamilton, Ohio, working on an RO system. Yeah, that's fun. Mike Mitchell, MM Creative Solutions. Mike Mitchell, I'm guessing. Very cool. Small business up in Ohio. Multiple water and wastewater projects with the Micro850. Well, this one's right up at you. Hey, Brad, good to see you. Brad has been here a couple times. Version 20 of Studio. So we are actually getting ready to do this in Studio 5000. You'll look forward to that. And got Doug Baker at Purdue Farms and working on an ignition project. Well, very cool. And Jane Drew River Campbell. Oh, welcome from Canada. And working in the industrial automation and controls in North Island College. Very cool. And hey there, MB. All right. So now that we have this part done, let's talk about this feedback because that's the next really tricky thing is so what it wants you to do is take your PID output and bring it around to your feedback. And let me see if I can at least get that wide now. No, don't do this because we need to talk about it. That's kind of what it's expecting you to do here. But when I say that what you see is what you get, this is all there is to this. So what is our output range that we're going to be working with? So if we go back to our main routine, we have 0 to 100%. That's really going to be our speed command that we're controlling this with. Well, this thing will keep on climbing and keep climbing and keep climbing to 65,000 something another. So we're going to need to limit it. Now, this is important. In fact, this right here is by far the biggest issue I see with anybody that says that their PID does not work the way they expect it to, is we need to talk about data types and how a simple misstep in your data type can cause you a lot of headache. So I even said it, we need to limit our value here. So if I drag an instruction block in and we double click on it and I start typing limit, we see limit integer to a specific range. An integer is a whole number. So our drive speed is 0 to 100%. That means we have 50 or we have 49 or we have 51. We don't have any decimals in between those. And here's where usually somebody starts typing right away. Well, my process is not that critical. It shouldn't matter. Well, yeah, you'd be surprised the times that it does matter. So I'll have somebody be like, yeah, it always seems to be searching. And I'm always like, okay, is it like kind of sinusoidal? How we pronounce that word? Is it like kind of ramping up and down, or is it like up, down, up, down? They're like, it's up, down, up, down. And I'm like, 100%. I know somebody has dropped an integer somewhere in there and you're having a rounding error. So that drive wanted to run at 49.3%. But since somebody put an integer in there, it's going to jump between 49 and 50, 49 and 50. So I don't know why, but there is no way in Connecting Components Workbench to actually limit a real number. But it's a great learning opportunity because we need to make a user-defined function block. And we arguably need to define what a user-defined function block is. Because one thing that a lot of you have asked is, how do you create routines inside of these? Well, you arguably can't create routines that run separately, but we can create user-defined function blocks. So now, if you look through the truth table of it compared to Studio 5000, they're going to call these add-on instructions. Now, I would argue that an add-on instruction is just a really pretty skinned subroutine. So this is what we're going to do is we're going to make a user-defined function block to fix this. So let's right-click, add, and here's one of those times I know some of you grumble, but this one's probably easiest to do in structured text. So let's make a structured text one, and we're going to call this our limit real. And let's double click on our local variables. And so we want to put in our minimum. Well, actually, no. Our first thing would be our input. And it's going to be a real number. And then it's going to be an input to our function block. Then we're going to have our minimum. And it will be a real. And it'll also be an input into the function block. Then we're going to have a maximum. And it's going to be a real. And also be an input. And then finally, we're going to have our output. And that will be an output out of our function block. And then let's double click on the lim real, and that's going to bring up a structured text program. And we're going to do some basic if-then statements. So if, and it'll be a miracle if I get my syntax right the first time, but we'll see how it works out here. That pop up out of the way. There we go. So if input, and notice since I added as a local variable, it's there. Input is, and first we're going to start with greater than the minimum and input is, oops, and I always forget all my parentheses. I need a parentheses there. think. Yep. And input is less than, and somebody will get on me if I don't do it. This actually should probably be a less than equal to, because I know somebody's going to ask if I don't do this. So if it is less than or equal to the maximum, which arguably means that it's in range, then output colon equals input. So if it's in between the minimum and maximum, we're going to make the input equal to output. And then we'll put a semicolon there. And then we'll put an end if. And semicolon there. And then we're going to do it again. So now we'll do if. And this time we're going to say if it's too low. So if input is less than the minimum, then, and in this case, output will equal the minimum. Oops. I always forget those semicolons. Hopefully I'm getting these right. Then we'll do an end if, and another semicolon. And now, arguably almost have the same thing. Say I'm going to copy and paste these three. Well, I have no idea what just happened there. Well, that's just weird. There it goes. That was weird. Oh, it is angry for some reason. Well, we're going to save that. And let's open it back up and see what happened. Well, my computer is like choking hard here. Okay, well, I don't know why it's choking, but let's go right back in. There it goes. That was weird. And so if input is greater than the maximum, then output equals the maximum. And then we end if, and by some miracle, let's see, I'm gonna go ahead and hit the build button up here because it seems like I always leave out a parentheses or something. Unknown function. Oh, well, yeah. Okay, well, that's exciting. This is the only error I have because it's what I drug in. So now, since we've made a limit real, if I double click back on this, and earlier when we typed limit, we had that limit integer. Now we have a limit real. And so now we'll take this line out. And actually, we're going to take this and shove it over here because we want to limit that drive also. So we're going to put that there. And then this will be the output to this. And you got to love how sloppy my, well, come on now, line up. There we go. As you can see, you got to love how sloppy my function blocks get to be, but that's just not even on me there. All right, then we're going to put this here. Whoops, you got to watch out for that though. See how sometimes that auto connect can hurt you. I'm going to put that there. We'll delete this one. And so now our minimum is 0.0 and our maximum is 100.0. So this is going to clamp our value. Now, see how these are truncated? I don't like that. So I'm going to widen that out. There we go. That's going to limit this output between 0 and 100. And now we're going to bring that back around to this feedback. It didn't do a great job at that. So we're going to try to drag that around a little bit more. There we go. Okay, so we have a speed feedback. We have a PID set point we haven't really worked with yet. And then we have our PID output. Now the PID output's just floating in midair. It doesn't actually do anything. So now let's work on our handoff auto a little bit because we already have it, kind of. If we go over to our main program, we already have hand operating our drive run. That was this one. And we need auto to operate it too. So we're going to drop down a branch here. And actually we can copy this and we'll paste here. And then we'll grab 13. So that makes it where it'll run in hand or auto. Now, right now, we have speed command. And if I just cross-reference it, it's not actually used anywhere. So now what we need to do is we need to have it run at a hand speed when in hand and grab that PID speed when we're in auto. Now, a lot of people will want to put it right here, but I kind of say define your rung based off what the output does. So this has to do with our drive run, not our drive speed. So I'm going to bring a new rung down. We'll just bring it down right here. And yeah, arguably have the exact same thing that we have up here. In fact, yeah, we can. Well, we'll go and bring a new branch down. And we can copy this. And we can paste it right there. Oops, didn't quite get it right. And then we can copy this. And we can paste it right here. And then, yeah, we're going to want a move instruction. So in hand, in the end, we're going to want to MOV, move. And this will be our speed command. And on this side, this is going to be our hand speed. And notice in this case, it defaults to a Boolean. We want that to be a real because we want to be able to put 49.2 in. There we go. All right, so then when we're in auto, we're going to want to move. Right, I don't think that works in connected components, does it? So Brad just asked, can you control drag in connected components? And it does not work. I was holding the control key there. It should work, but it doesn't work. Well, we could go ahead and try something crazy like the shift key. Nope, same deal. No, so we're copying and pasting. So copy, and we're going to paste this here. Oops, and even then I pasted in the wrong spot. Okay, so now for our auto, we do want that PID output. So that's going to be PID output. Oops. Let me clean some of this up. Got too many tabs open in my brain now. I'm probably going to open half of them right back up, but let me get these closed. Okay. All right, so that takes care of our speed feedback. We're going to come back and talk about our set point here in a little bit. But all right, we have the auto, we have the initialize, we have the gains, and the auto tune. Now, really, we want to focus on the auto, initialize, and auto tune together. And I got to tell you that this is not something that was super abundantly clear in here. But if we go to Rockwell's knowledge base, and this does have an access level of everyone, so you can get to this one, QA 22011. It kind of walks you through how to set this up, and roughly it's what we're walking through. But the one thing that was not really clear was this initialize and the auto. And let me see if I can find it really fast. Whoops, we're already into the auto tune procedure. Mainly, where is, and I may not even be able to find it fast enough. Let me just control F for it. That would be the smart thing. All right, so they have it during the auto tune. Okay, in this one, it was not super clear. But pretty much when you start this PID, you want to start the initialize. Now, we also have an auto tune we're going to have to deal with. And so when we're doing the auto tune, we're going to need to turn the auto tune on also, and not the PID auto. So it's going to get really confusing really quick. So let's just start dragging some stuff into our main routine and see if we can talk it out. So actually, I'm going to put these at the very top because really we're talking about this auto right here. So I'm going to copy it. So one of our modes is we're in auto and we are not, and we need a tag for this. We are not, let's see, we're going to call it auto tune mode. Auto tune mode. So if we're in auto and we're not in auto tune mode, that means that we are going to be running our PID normally. Now, I could do some really fancy logic to do this, but I know y'all shun me a lot of times for using, or say I should not teach anybody about a latch and an unlatch. This may be the one time that I'm not sure that there's a cleaner way. So what we're going to do is we're going to bring down the set bit, and we're going to set the PID auto, and then we're going to put a branch around that. I don't know why it won't let me drop it right there. Sorry, we can click the shape, drop it over it, and then we're going to bring another set down. Actually, yes, we're going to bring another set down, and we're going to set the PID initialize. And then let's bring another branch down. Actually, you don't need to. We can just right click right here. Oops, if I can get in this spot. There we go, right click. Well, come on now. Well, apparently I can't aim good enough. All right, we'll just drag it. There we go. I was trying to show you an easy way. Now, in this case, we do not want to auto-tune because we're not in auto-tune mode. So we are going to reset or go right a 0 to the PID auto-tune. Now, be really careful. We're getting a lot of autos and tunes and all types of things. So that's one mode. Now, the other mode is if we're in auto-tune. So we're going to copy, and we're going to paste this whole rung because it's almost the same. This right here needs to be a go look for one. Now, I can't remember who showed it to me first, but now Brad talking about amazing features. If you did not know this one, if I highlight this and I hit the space bar, you can toggle through the different versions of this. So there, we want to go look for one there. And if we're in auto tune mode, we don't want this in auto. So I hit the space bar. That takes us to the reset. And then we need to be in auto. Oops. So we'll come around to the set. So that is the combination of these three when we're in auto. And then finally, we have when we're not in auto. I'm sorry, that was auto and auto tune mode. And finally, when we're not in auto. So we're going to copy this rung one more time, and we're going to paste it in. And in this case, we can take the auto tune out. I'm going to hit the space bar on this for a go look for a 0. And in that case, we want to reset all three of these bits. So first, we're in auto or we're not in auto. Oops, I did the wrong one there. It's all right. We'll drag that up. I think I did okay in the end. I just put it in the wrong spot. So we're in auto and we're not in auto tune mode. We're going to turn on our PID auto. We're going to initialize our PID, and we're going to not have the auto tune on. The other is we're in auto tune mode. We switch it to auto. We're not going to be in auto. We are going to set our initialize, and we're going to set our PID auto tune. We're going to need that in just a second. And then finally, when we switch it out auto, we want to clear all those bits out. Okay, so that gets us through that. Let's go back over here. So that takes care of the auto. That takes care of the initialize. We're going to come back to the PID gains because we need to use the auto tune to do that. That gets us through this auto tune, and that gets us there. Now, we are not done nearly, but we are close enough that we are going to go ahead and download this and see what it does, because chances are this is roughly where you'll get to. And well, you probably have downloaded 4 or 5 times by now before you ever found this video, but this is probably where we get to, and then we start running into some issues that we need to understand. So let's go ahead and download that. And if you need any help downloading your program, or you're like, man, I don't even know how to download Connected Components Workbench, which by the way is free from Rockwell Automation, then look down in the description. There's a course on how to do all of that. And whoops, there it goes. Apparently my computer is choking. I don't know why today. Apparently it's not liking streaming and liking doing Connected Components. All right, well, I got the right PLC because I got a red flashing fault light. That's always good over here. And we'll put it back into run mode. Okay. Now, immediately, and you need to be really careful, especially if you have an application like mine where the motor running really slow can overheat it, is let's go back to our main and let's see what our speed commands are going to be now. So we have hand and we have auto. We know our PID output we got to work on. But also, since we created this hand speed, notice that it defaulted to 0. So we need to change that. And I'm going to put it at 25. And now, if we switch it over to hand, our motor does run. Now, if I switch it to auto, then I hear the motor enable, but we are not putting any real speed out. Now, it's still putting some voltage on it, and that will slowly overheat that motor. So now let's look at our PID and see what we have here. So we see, in fact, look, here, now, here's where all of a sudden it's like, what's going on? See, it's trying to climb a little bit here. Now, we feel like and I know everybody, half of you know we need to auto tune this, half of you aren't sure, but you feel like you want to put a speed set point in here and watch this thing go. And so let's do that. I'm going to put 900 in here. And notice our output starts going up. And if you wait long enough, it'll go up forever. Now I'm going to switch it over to auto. And we're going to hear it very slowly running, but it's trying. I probably should have let it go up a little further, or I should have put my set point a little slower, but we're going to wait here. Now, absolutely brutal as this is to watch, the PID arguably is trying to do something here. Now I'm going to switch it off, and notice it's still kind of just climbing there. And so this is going to be an issue. Now, I know how to fix this, but I don't want to fix it yet because y'all probably won't have thought of how to fix it yet. And honestly, I haven't seen it documented how to fix this piece right here. But we know we want to auto tune it. So let's go back over to Rockwell's knowledge base on this. And let's talk about mainly this section right here. So what it's saying here, oops. Okay, so we pretty much have gotten it to this point right here. The PID control is fully functional. Now, notice this gain proportional point, or it's 1/10 of a thou, and integral is 1/10 of a thou. And actually our derivative is 0. That's what we're dealing with right now. So that's what it's kind of doing there. So if we open it up, those numbers are way the heck down there near 0. So we've got to get some numbers into that. Now, don't just start throwing numbers into it. Most softwares have some type of auto tune now, and that'll give us really close to where we need to be. And so now we need to do the auto tune procedure. So first it says make our set point 0. So I'm going to click my set point, and I'm going to make it 0. All right, next it says make sure that auto mode is not checked, or that it is a 0. Well, that's kind of what I was doing with this logic over here. Right. Is so if I check, see right now this has a 0 in it, that's setting the auto mode. But if I have my auto tune mode to a 1, that will not let that auto happen. So I'm going to right click auto tune mode, and we're going to toggle that bit, and that's going to get it ready for that. And then it says set all of the gains to 0. Now, one little hitch to that, and I assume it's so that you don't get super frustrated trying to make your PID operate, is if we actually go over here and double click our PID gains, if you try to put a 0 in here, it puts a 0.01, or it puts 1/10 of a thou back in it. So that's as close to 0 as we can get following their instructions. Okay, now this one right here gets a little tricky. So it says set the parameters for the auto tune. And we have the load, which is the initial value. This is pretty much what is this thing going to run to start with? And then we have the deviation. Now it says in this case, it'll be calculated later. And then we have a step. And there's a lot of different philosophies on this step. And I really would prefer you kind of play with the step a little bit to learn what works best. And then we have the time that we're going to allow it to complete this auto tune process. And then we have the AT reset. Leaving marked at end of auto tune process, the output, the IPID reset. I really have read this and read this and read this and read this, and I can't really figure it out, but I can just tell you we need to check this box right here. So we're going to double click on our parameters, open them up. And yeah, so first we have our load, and I'm just going to put this at 25. That's just, oops, lost my mouse. I'm going to put this at 25 because really part of our goal here is to get this to the point that we can play with enough to learn about these different parameters. All right, and it's said to wait on the deviation. We'll wait. And then we have our step size. I'm going to throw 20 in for not a lot of scientific reason. And then for our dynamic set or auto tune dynamic set, whatever that is, I'm going to put 600, and I'm putting that in just because Rock will put 600. That's 600 seconds, so that gives it 10 minutes. And y'all going to get really bored if it takes 10 minutes. Hopefully it only takes about 10 seconds. And then, yeah, we're going to check the AT reset bit. Okay, so that gets us through that. And then we'll drag this back over. All right, so now it says set the tag PID initialize and auto tune. Now we're not going to do that yet because I want us to understand what we're doing here. At this time, the output of the IPID is set to the value in the load. So in their case, they had 50. I threw 25 just because 50 kind of makes the mic have a bad hiss on it. And then we need to monitor our process variable. Now the process variable is this part on the left side, the speed feedback. And they're saying to observe its min and its max. Now, probably if I was doing this a lot, I probably would write something to capture this min and max, but we'll eyeball it. That'll work. And then it says subtract the max from the min and divide by 2 and put that into that deviation parameter. Then you uncheck the initialize box. And we should see the AT warning go to a 1. We should see some things happening here. We hope. And most importantly, if everything is done, we should see the AT go to a 2. Okay, let's see if I can remember that well enough to do this. So we already have our checkboxes set up because we're in auto tune mode. As soon as I switch forward to the right, which will be auto, that is going to set the initialize, that's going to set the auto tune, and that should get us running at our load, which is 25. So I'm going to switch forward to the left, I mean to the right. Okay, then no doubt we have 25 on our output. And now we're supposed to stare at this value, which is honestly slightly too small for me to even see, but I think I've seen 870 and I've seen roughly 890. Yeah, so we should write something so we're not staring at this. I'm going to arbitrarily say 10, and that's very arbitrarily. So then I'm going to double click on the auto tune. And in that deviation, what we're saying is, hey, if this thing is steady running, it has a deviation of plus or minus 10. Okay, now it says to uncheck the initialize box, and hopefully we see this go to a 1. Then we see it go to 2. And then very important part, because you can get really caught up in the weeds of the numbers, is be listening, because after that, it's going to set your drive commanded speed back to 0. I talk to people in our class all the time. If you're applying 0 speed to a motor, it is still putting some voltage on that motor winding. And a fan cools itself by rotating. So you listen, make sure that you're not running this. But all right, so we're going to do it. We should see it go to a 1 here, and then hopefully shortly after a 2. So we're going to right click the initialize. Whoops. Oh, that's right. You can't toggle here, but all right. Now, okay, there's 2 ways to do this, and I'm going to do it the second way because I want you to be able to see it. If I think this is developer only that you have add to SPI list. If you don't have developer, you can simply double click on it and you can uncheck the box. But I want y'all to clearly see what happens over here. So I am going to right click the initialize and I'm going to add it to a SPI list. And here's my checkbox. I uncheck it. Whoops. I did something wrong. Oh, whoopsies. I got a problem. And I see what it is. The whole point of the set and unset from earlier was I only wanted these to write 1 time. I have a go look for a 1 here. There should be a pulse, or in Studio 5000, we would call it a 1-shot. So a couple things. This is a good learning opportunity. You want to get everything out of it. So hold on. Don't go offline yet. Let's talk through this. Is remember we've added serval values here, such as these, our hand speed and other things. These values are not in your Connected Components Workbench program. They're only in the PLC. Now in Studio 5000, we can simply hit the Save button, and we would get a prompt saying, do you want to upload your data table values? That does not happen in Connected Components Workbench. So in this case, what we want to do is we want to disconnect. Then we want to right-click the Micro850 in the left pane, and we want to upload. And then we're going to upload with logical values. Strictly amps. Oh, Armstrong World. Okay, in Macon, Georgia. Servo-powered tipper conveyor. That sounds like a lot of fun. Well, they know servos. They're pretty sophisticated PIDs there. Okay, upload succeeded. We're going to uncheck it. And yeah, I made a mistake earlier. And then here's where the cool space bar comes in. I've highlighted this. I'm going to hit the space bar and I'm looking for a P. So I have to go look for 0. This is going to be on when for 1 time when it goes true. Now, if you're not sure about these, all you have highlighted, hit the properties over here. See, it says pulse rising edge contact. That's what we want there. That's also what we want here. Now, this one needs to be the opposite, and it's called an N. And if I highlight that one, oops, then it's pulse falling edge contact. That's what those should be. I think it's just those 3. I kind of thought about this morning. I was like, I think this would work. All right, let me download that. Let's see. Ardash, can you please make this as a video also? Really appreciate if this content was provided as a video so we can read. Oh yeah, so all of our live streams are available later on. So yeah, hit that subscribe button down there and mainly then go to our channel page. And yeah, you can see all our past live streams. And so this is a series that we've been building. Actually, so I've had a lot of schools ask, can you make one comprehensive offline project or offline video for us? Because some of ours, you don't have access to YouTube at schools. So first of all, why do schools not have access to YouTube? Doesn't make any sense. But so yeah, we're actually going to make a combined one of all of these live streams that we've done on the Micro850. I think in the end it's 14 hours. I don't know why anybody want to listen to 14 hours of me, but yeah, so that'll even be available. All right, so now we'll put it back into run mode. And since we went offline, since we went offline and then we uploaded, when I go back into my PID control, then when I double click on my auto tune parameters, everything is there and ready. So still including my 10 and my deviation. So I don't need to do that again, but mainly my auto tune. Let's go check and make sure, but I am in auto tune mode still. And so the moment that I switch 4 to the right, it doesn't do anything. Well, that's the disadvantage of a live stream, is now I got to figure out why. Oh, it worked perfectly fine. When you download, it does break the connection on the PowerFlex 525. And yeah, there. Now we're ready. So let's try that again. Switch 4 to the right. And a couple things to be observed, and when I uncheck this initialize, if it works this time, you'll probably see this output value here change where it's observing how it changes when it does that. And hopefully, if I did everything right, you will see this go to a 1 and then to a 2. So now I'm going to uncheck the initialize button. And well, there you go. So it went up to 45, it went down to 5, bounced a little bit more. Oh, that is something wrong because we don't have a 2. We'll give it a little bit of time here, but I'm going to guess that I missed something. Not an auto. We have auto tune. Yeah, so mainly we're looking for a 2 here to say that it finished. But yeah, if it hasn't finished by now, it's not going to. What did I do wrong? Or am I wrong about this checkbox? Does it need to be unchecked? Now I'm not remembering myself. Well, let's see. This is set gains to 0. Yeah, the checkbox was the one, even the first time I did it. It's like I cannot understand what they're trying to say here. All right, let's try that again with the box unchecked. Well, I swore in the end I found out that was the issue, was I had to check the box. All right, we'll let it get down to a stop. Actually, we don't need to let it get down to a stop. Or switch 4 to the right. And we uncheck the box. Ah. Hello when this happens. All right, where did I go wrong? Well, let's just hit all the basics. I'll let that run while I do it. But we have it in a periodic task, or as a selectable time interrupt, and it's 200 milliseconds. That part's right. Okay, my speed feedback is right. My set point is at 0. I'm looping in that, limiting it between 0 and 100. All right, I missed something though. That's false. That's false. Let's see. Now I did try this morning. Let me open up the program that I tried it in. Let's go see what I did wrong. See, R2A. Hi everyone. Greetings from Costa Rica. Show all variables in panel view 800 is a headache. Show all variables. You mean like finding program tags versus controller tags? Or dash, let's see, I am a big fan of your content. It has really helped me out. I'm a control system integrator myself. Love from India. Well, great to have you here. Let's see. Well, apparently we're still opening over here. But yeah, that should have been it. I've missed something. So let's see here. Let me go to this one. and just see what I did wrong. Well, that looks pretty much exactly the same. Got a few words different, but no, that's pretty much what we have here. Let's see, what did I make this one? So now I did arbitrarily throw an interrupt rating in it. Let me, no, I did 200 milliseconds there. We know it's running. Let's go see what I made the variables in this one's auto tune. Well, I have a way lower number in this one. Well, a higher number should make it easier, I thought. I have a lower number there too. Okay, well, maybe we do need to do a little work there. Okay, let's try it. So let me, because I can't think of anything else. Speed feedback. Auto tune, gains. That should be it. All right, well. So let's see. I don't want that higher because yeah, that'll blow y'all's eardrums out. But if I put that lower, I swear that makes it worse. Well, just because I got to try it, we're going to put 20 in that one. And then we switch it back to auto. We have the initialize, we have the auto tune. So I should be able to uncheck the PID initialize box. And it does not work. So, but all right, let's go back to this one check box because I swear this box right here is what I battled last time. I swear that thing's got to be checked. Switch it off. It's pretty steady. Huh. Oh, there it goes. Okay, well, now I want to put that back where it was. I swear it's that checkbox. That checkbox like whipped me the first time I did this. I want to put that back at 10 because that seems really high now. Switch it. We uncheck it. Okay, I cannot explain to you that checkbox. We're exactly back where we were. But mainly we got a 2 here, and that was the success we were looking for. But there is something really funky about that box. So apparently running and checking, running and unchecking, I have no idea. But okay, all that to get to this PID out gains. This now has its recommended gains in it. Now, coincidentally, since it groups it by gain PID, right above it, here's our current gains. And we probably could put some software code in to do this, but I'm just going to copy that. And I'm going to paste it. And then we're going to copy this one. And we're going to paste it. And then we're going to copy this one. And we're going to paste it. There we go. Okay. There's one additional thing that we have to address. So now we want to put our set point back where we were. So I want to put it back at 900. And I have not seen this documented anywhere. But this is what I came up with is we're at 900. Look at our output. It is just climbing and climbing and climbing. So now when we try to switch our PID on, it's going to start off wide open. Now, there was a lot of documentation that is completely gibberish about how this PID auto works, but it does not do what you think it does, such as switching between an auto and a manual mode. In fact, if we go and we look at, let me get that back up here. Yeah, let me search for auto. Of course, auto tune is going to be in here 50,000 times. Where's the auto? Oh, it's in here somewhere, but it's 100% gibberish what they say it does. Let's see, or is it not in this one? Okay, well, I was hoping it's in this one because this one is much easier to find stuff in, but that's all right. We got the manual here because I was like, we may need this. There we go. Well, there it is, auto mode. Now, true, controller runs in normal mode. Well, you're going to have to define normal for me. False, derivative term is ignored, forcing the controller output to track the feedback within the controller limits and allowing controller to switch back to auto without bumping the output. What the frick? I have no idea what they mean, and yeah, when I looked it up, all I could find was a boatload of questions about the same thing. And so that is not what we want to do. Whoops. Now have I done this? Oh, I drug a screen to the wrong spot. Now I got to get all my screens back. There it is. Get that one back up there. So what I found is if the set point was at 0, then our output, oops, except we got to get that going. All right, let's just try it first so we can see exactly what I'm talking about here. Is I'm going to switch it to auto. Whoops, I got to put it back at 900. And we switch it on. Whoops, you got to take it out of auto tune. Back to main, and we're done with you. So we're going to toggle you back off. And now we go over here. See, it like went wide freaking open and then dropped back off. Now, if that set point started out at 0, then it seems to drop down. You can see the output dropping now. It'll drop down to 0. So what I did, and again, I hope somebody corrects me and shows me a better way, is I made it so the PID set point is 0 when we're not running, and then I take it to the desired set point when we are running. So I'm going to disconnect, and we are going to open up our main program. And then, yeah, we already have some handoff auto logic right here. Is I'm just going to add another rung right beneath here. And in this case, actually, no, I was getting ready to repurpose a rung, but no, we don't want to repurpose a rung. If we are in auto and we are not in auto tune, now what did I call that? Auto tune mode. Then I am going to move we're going to call it our speed set point to our PID set point. Now, if we are not in auto, or we are in auto tune, so not in auto, or we're not in auto tune, then we're going to move. I know this is going to paste in the wrong place. It irritates me. Oops, undo. Never figure out how to paste right here. I want this to go right in here. Anybody know how to do that? Man, it always ends up over there. We're going to move 0.0 into there. So this way, when we're in auto, our PID set point will go to whatever we want it to be. And we're not, we put it to 0. And this is the best way I've found to kind of make that PID stay calm down while we're doing it. Okay, let's see. Where am I at over here? Let's see. Strictly, if you're, yeah, I'm doing all this in CCW. We're getting ready to do this whole thing in Studio 5000. Let's see. Oh, I just missed that question. What the heck is a PID? Proportional integral derivative. It's used a lot in process control. So let's say we have a temperature burner system. You know, we're trying to attain a temperature of something, have a combustion valve on it or something, something we can adjust to try to keep something at a desired level. Let's see. How do we enter the KCTD and TI values? I'll show. All right. Well, I may have already done that. If not, we'll bounce right back there in a second. Let's see how this works though. So we are going to, oops. So I'll hit that first. So if we go back to our PID, then the PID gains is where that actually is. And in your case, there's the proportional, the integral, and the derivative are right there. Okay, now we're sitting at 0. We're going to put, oops, we are going to make sure that because yeah, our auto tune is going to be back on. It's only I don't like. And then, whoops, and what else did I do wrong now? It got me again. Every time we download, it faults the drive because I lost my Ethernet connection. Oh, that actually sounded pretty darn good. Am I in manual or something? Let's see here. We're in auto. It's definitely varying. We can even go, okay. All right, so that it could be surprising, but that actually seems like it auto-tuned incredibly well. So if you remember from our last live stream, the last piece of this is in ignition, I had you set up your speed command and your speed feedback. Now, one thing I've added is our speed set point. And our speed set point does need a value in it. So no, I don't believe this is actually working that well because where is our speed set point is currently 0. 900. Okay, we switch. Oh, did I switch to hand? I did, I think. Okay, so it is adjusting incredibly slowly is the issue we're having now. But why did that not set it to 0? I did something wrong there. PID. Oh, all right. Let me go back to this other program. I think I just flipped these around because let's see, this one's a little bit different, but what did I do differently? Actually, mainly, oh yeah, I told you completely. Auto speed command. We're going to cross-reference you. Right here. When we're not in, I did it to the set point. I meant to do it to the auto speed command. It's supposed to be at 0 when we're not running. Oh, thank you for telling me. How long have I been not being able to see the screen? That's okay. I told you one thing wrong here. We're going to go back offline. Sorry about that. If Amber's here, she'd already told me that. But okay, I'm gonna blame her. Um, so yeah, I told you wrong here. I said change the speed PID speed set point right here. We want to change. In fact, I'm just gonna add another run because yeah, that gets a little clunky there. If we're not running, it's the PID output to 0. I mean, Hardash, you don't like just seeing my face? I got a heck of a delay today. I'm not sure what I've done, but yeah, I got a lot of things going on with the computer apparently. Remember to reset the drive this time. All right, there we go. Now we switch it. Oops, actually, I'm not even sure why it is trying to though. All right, I've still got something going on. Well, I want it done at 900. There we go. Now, why is it staying fixed at? Oh, okay. No, initial. Oh, I forgot the auto tune again. Like, why is that staying that way? But yeah, we're in auto tune mode. Turn that off. Why is the set point not going across? Oh, because, yeah, I kind of botched that there at the end. Speed set point. PID? Where's PID set point? Did I take that out by accident? Oh, the speed set point. All right, I think I did just botch that. What did I just do? Cross reference. Did I write this? No. I think I just entered a value in the wrong spot or something. Thought I just entered 900 here. 900. Got the cold fog in my brain here. Now let's see. So switch it over. All right. So we have a very slow response right now, but we are getting there. We definitely gonna have to do some work on that. Well, now let's see what this looks like. All right. So we are climbing. All right. Very slow and steady. So this would definitely be a example of a slow responding PID. But eventually it will get there. But all right, I already grabbed some other settings, so let's see how those work. Because over here, actually, oh, I closed that. Hopefully I didn't mess everything up because I had some settings I was going to paste. Oh, okay. Well, we're going to try the auto tune again then with the new settings and find out how it happens. So now we're going to toggle you And then we go back into here. Oh. Oh, there's what I did wrong. Remember I told y'all you got when you go if you download, I didn't have those. I was like, why is that running so slow? It doesn't have any of the auto tune parameters in. So you get to see me tune it again because I forgot to upload after that last change. That's all right though. So we are in auto tune mode. We switch over. We look good. We right click the initialize, add to spy list. Oops, well now I have it twice. Uncheck it. All right, and now we got that whole funky thing with this thing. I've got to figure, this is the one part I hope somebody can explain better to me. I really would love not to just check that box and uncheck that box and do it again. But I think that's the insanity piece that gets us there. Uncheck. And then we do it one more time as insanity. Maybe that is not it. I've got to figure this one piece here. Check the box again. Of course, I did change the 20 last time. Maybe it is that my deviation is too tight. No, so somebody one day is going to have to explain to me. So we have an auto tune of two. That means we're successful. Somebody's going to explain to me this whole craziness with this AT reset parameter here. But yeah, that's why I end up fighting it every time. So if you're struggling to get that two up, try auto tuning with this off and then turn auto tuning with it on again. As insane as that sounds. But okay, now we have our PID output gains, which embarrassingly I forgot to save. Hopefully they're about the same numbers. So we copy that. And that'll be our proportional. We copy this. That'll be our derivative, our integral. We copy this. That will be our derivative. Okay, so now we turn off, oops, we turn off our auto tune. Didn't mean to pin you. Oops. And then, actually, we should be able to do it from over here. We have a speed set point of 900. All right, so we got a little jaggediness here to work with, but all right. There's our first run of this thing. I know that was an incredible amount to go through to get here. But all right, let's talk a little bit about ignition here because at the end of the last video, I realized I didn't change this time span. This is way too long of a time span for us to really be looking at this. So what I want you to do is we're going to hit the play button up here. Now we can drop this number down. Let's bring it down to a minute. That gets us where we can kind of see what all is going on here. And then even then, well, no, because now what I want to do is I want to change our set point. We want to see how this responds because, that's part of it. One, it's cool that you can get it to smoothly come up. We definitely got to do something about that little jagged peak. But what happens if we change our set point now? Now, did I make this so I could I didn't make it so I could change it in ignition. That's all right. To show how easy we can make it change in ignition, we're going to hit the stop button. And we are going to bring in a numeric text field. Just going to drop it in. We'll drop it right beside of it. That way it's halfway labeled. And over here, here's our speed set point. We're going to grab it. And we're just going to bring it over that yellow part. And now I should be able to change. Oops, got to hit my play button. Now I should be able to change this one to 1800. Oops, and all right. So I don't have it set up for read write right now. So I go to project, com read write. And now I'll have to enter 1800. All right, you can see we still got the same kind of similar little overshot right there. But that gets us to where we can play with this now. So now what we want to do, now I'm getting ready to pass it over to you to do, is what we want to do, you want to do is let's not make myths about what the P, the I, and the D are, because, I think in every PID video, I hear people say, well, P is your past, I is your present, D is your future. That's no. So what we want to do is we want to play with it and figure it out. So first of all, we have the auto tune. After we do that funky checkbox, in fact, let me go ahead and try it one time just to make sure no insanity happens here. But if I was to take my auto tune and it seems like after you do that one time, this works, but let's find out. If I was to change my step size, I don't know, to 15, and then we go enable our auto tune, then we switch forward, and we uncheck it. Oh man, I got to figure out why. There's something funkier. Actually, this may be on me. Actually, I would. All right. Now, here's where we do need to start. And here's part of it. You need to start understanding more about these. I dropped that step size down and probably made it where that deviation was not large enough. Let's make it 25. Then we'll go the opposite direction. Oops, I can't go to 25 because that would put me at 0. Oh, let's just put 22 in just so we have a different number. And then we uncheck it. And let's just go see if those parameters look any different. They probably won't for that minute of a step size. We need to actually change our variation too. Well, actually, there is a slight difference in those numbers, but okay. Now let's just throw them in just so we can see that it may be different. It may not be. I doubt that is enough to make a difference, but let's go over here now. Oops, I should have put that auto tune on the selector switch. Now we go over here. We switch it. Oh, yeah, it definitely did not like that. Now, one thing we tuned it for a much lower starting frequency. Probably should have had this up in the 50% range when we did it. But all right. Now you want to know what does the proportional, what is the integral, what does all that do? Then let's take them one at a time. Now, one at a time, I said, is yeah, there's nothing worse, especially on a PID, than changing 20 things. But now let's get our gains. All right, we want to know what does the proportional, how does it affect it? All right, now this is 0.03. What happens when we make it 0.01? And then we go over here. Whoops. So that was our previous graph. So we see it definitely had less of a curve over, less of an overshoot, taking longer to get there though. And yeah, it finally does get there. Oh, don't worry about that. That's a flaw in my program. Noticed that earlier. Okay, but the goal here was to get you set up where you could run a PID in the Micro820. I'd say I'm not a super fan of the PID in the Micro820, and this is why I find a lot of people they end up rolling their own even because it is just the calculation piece, and especially if you're coming from studio or something, it's like we have manual control, we have all these different things, all types of cool features, but the big thing now is instead of taking and saying, well, I think the proportional does this. What happens if you double the proportional? What happens if you change the integral? And just start to observe and learn how the different ones change the different values. But that is it for this series right here. So not that it's the end of the Micro850, but this is kind of what schools asked us to work through is, can you take us from the very basic instruction to PID? So there it is. And yeah, there will be a 14-hour version of this if you really need something to put you to sleep. But anyway, that's all I have for today. Till next time, have a great day.